Okay, so our final presentation at the lightning talk round is George Rath, who will be talking about Slurm. So take it away, George.
Okay, hi, I'm George. I'm going to present Slurm in action batch processing for the 21st century. We're going to make batch processing cool again, apparently. I work for NERSC, which is the primary scientific computing facility of the Office of Science. We have 2 supercomputers, Cori and Edison, and 3 smaller clusters, and together that's around 800,000 cores, 50 petabytes of storage. We serve 6,000 scientists from very different fields, and everything we do is open science. So what is Slurm? Slurm was formerly called the Simple Linux Utility for Resource Management. When they reached 500,000 lines of code, they got rid of the simple, so it's only called Slurm now. It's a highly scalable workload manager. It runs on, I think, 10,000 nodes on Cori, and it runs on bigger systems than that as well. It's like more than 60% of the 500 fastest machine in the world runs Slurm. Development started in 2001 at Lawrence Livermore National Lab, and it's now maintained by a company called SCADMD and a pretty active open source community. So, how many here do have an HPC background? Oh. Well, we're going to start at the basics, so you might know a lot of that stuff, but the basic functionality of Slurm is you write the job script, you submit it to Slurm. Inside the job script, you do whatever you want to do. Your job is queued, and the priority is applied. So if you submit a high priority job, it runs first. And then when the job gets to run, it enforces resource limits using C groups, tracks the usage, who ran the job, how long it took, etc., and then tears it down when the job is finished. So some of the features of Slurm which make it nice to use from the administrative side: it's very easy to deploy. It has a single configuration file. The documentation is extensive. It's pretty user-friendly, if you're coming from HPC, I guess. It's highly scalable and extremely configurable, which is a good and a bad thing. So you can do anything you want to do with it, but it can get out of hand if you're not careful. So the architecture is pretty simple. You have a controller, a database server that keeps track of the jobs and the resources they use, runtimes, etc. You have a Slurm-D that runs on the compute nodes, and it talks to the other compute nodes in a hierarchical fashion. So it scales pretty well. And then the programs use like S-control, which is used to check the state of the nodes, and SQ to check how the jobs are queuing, go against the controller. It's, I think, prudent to note that there is no single point of failure, so you can have it running pretty much disruption-free. So I'm going to give you an example of a job array. So let's say you want to do some image processing, as it's fashionable now, and you want to get, so you put a bash script, a really plain bash script. You put the sbatch directives that Slurm interprets on top, and then on the bottom you run nowadays your Docker container, right? So you give the job a name called image resize. You say, I want to run 100 of those jobs. So this is going to get executed 100 times. You want 2 CPUs per task, and you want 10 gigs of memory per task. So, and then you type docker run, your Docker container, and you set the environment variable input to the task ID of the task that you're currently in. So the first task is going to have input equals 1, then input equals 2, 3, etc. Because this is a reduced example, you would usually get the input files out of a file, like the first, second, third entry. So what you also can do is you can build workflows on top of the scheduler. So you can say, I have a high priority, that's my AI job, also fashionable now. It should use 5 nodes, and it can only run after, let's say, the image preprocessing job has finished. And the Slurm is going to take care that it executes in order. It also has advanced features, which are pretty nice. It has burst buffers. It integrates with containers, not only the way we just saw by executing Docker directly, but by using a plugin. You have a job submit plugin that can rewrite the job when you submit it. It can federate, which means you can run several controllers and you submit the job and it gets submitted to any controller. And it is a relatively extensive amount of plugins. So burst buffers are a thing that was developed with input of NERSC. We use it to provision storage for the Crate data warp system. So when you launch a job, you can say, okay, I want, 500 terabytes of SSD, and then you can use that inside of the job. So that's not useful for, I guess, anybody in the room except one guy. But you can also use a generic plugin that uses shell scripts, and then you can do provision whatever you want to in this, and you can automatically stage data in and out. For example, you could, so I do have to say full disclosure, that's not implemented yet, you would need to do that yourself using shell scripts, but you could pull data in from S3 and stage it out to S3, and then run your container and say, okay, this is my input, it's there because it was staged in by the scheduler, and when you're done, stage it out again. Container integration is realized by what Slurm calls a Spank plugin, which is a bit of an awkward name, I guess. As Shifter, which is a tool to run Docker on HPC systems, is developed at NERSC. There is a plugin for Slurm, of course. There is also one for Singularity, and it's very easy to use. If you want to have an interactive session that runs in some custom pipeline that you put together, you just do an SLOG, specify the image you want to run in. When you enter this interactive session, you're going to be inside of that container. There is a job submit plugin. As Slurm is very heavily C-based, it's based on Lua. So when you submit a job request, you can modify it on the fly and make, let's say, business decisions, which can be very powerful and very, very flexible, as you can access everything that the internal state of Slurm if you want to do that. There are more plugins like this, which you can write either in C or in Lua as well. The Lua part is also done by Lawrence Livermore Lab. So there are a few plugins floating around for, let's say, X11 support that forwards the connection back to your login node if you have different network setups. You can notify the user if he gets an OM. At NERSC, we have a thing that loads performance tools like the kernel module. You can request the kernel module to be loaded when the job runs, and then strips it down when the job is finished. As I'm running out of time, I'm not going to go too much into this, and as you all have an HPC ground, I guess you know how backfill works. But basically, the scheduler, if you have a big job that uses a lot of resources, you need to drain those resources first to be able to run it. And the scheduler uses that draining to backfill jobs that can take a shorter time to execute those, so you get a higher utilization of your resources. And that was it. Any questions?
All right, any questions? Hey, yeah, good.
I wanted to ask, do you also restart your systems after every application to run on bigger clusters?
Slurm does support restart. We have Intel KNL system, so you can run that in different nodes. So Slurm does support node restart, but we do not restart it after every job.
All right, and that concludes our lightning talk round. Let's thank George.